Hey, I hope you're all doing well. So for this solution, we're gonna actually go back and people ask, how do you know to do that? How did you know to do this thing? How do I learn that? What would make me think of that? Well, I'm gonna answer that question. We're first gonna go back to an older AMC question that might have given you some insight if you had taken the time to review the older tests. And so we're going to go look at that in just a moment. Before I get to my solution on this, it's actually not fully my solution. It's partially hat tip to King Ravi. He has his own channel called Gana Sonata. It's in my channel links down below. He's a fantastic singer. You should check him out. So in a moment, we're going to get to this, but first, let's look at the preceding thoughts. We'll be right back. So as noted in the intro there, we are going to take a look at another problem that precedes the one that we are solving right now. And that problem's understanding is going to lend insight. People often ask, how do you think of that? That thing that you did, how do you think of that on the test? How am I supposed to think of that? And one of the answers that you should make available to yourself is by solving lots of problems. And when you solve those problems, you're not just solving to do them, you're analyzing them for information, for techniques, for strategies, and then you're keeping track of those in a small notebook, which is what I advocate for, or at least somewhere record these kinds of ideas. Before we get to that though, I do want to go over, as noted in the thumbnail, my current class 2024 current winter class schedule. So currently, these are the classes that I'm offering. These are all Pacific times. I do have an Amy prep course. It is beginning tomorrow, December 9th. I have not made any announcement anywhere else until now, so it's kind of late to get this announcement out. I've been trying to get this video filmed for a long time, but just have not had time. So Tuesday, 5 to 6:30 is AMC 10 Pass Test Review, which is a course that you would learn some of the things I'm going to show you in this video. Okay. This course starts and does 1 to 2 to even 3 tests a week. In the beginning, we start at the year 2000, and we might do 2 tests a week. We spend an hour and a half, and I go through in detail and answer questions that you might have and point out things that I think are important. And slowly over time, we will work our way all the way through the 2024 tests, and this will end about next October to November. And right about the time that the test will take place, you will have reviewed all the past tests and gotten a bunch of new information, strategy, and analysis. Same thing for AMC 12. This class is going to be on Thursdays. So that class, they're both 5 to 6:30 p.m. Pacific. Fridays, if you're taking the AMC 8 or plan to take math counts, there is a class going right now. Coming up later this month, I am going to be going through speed mechanics in this class that you can learn faster ways to calculate things. That class is Fridays from 5 to 6:30. If you are in the middle of Intro to Geo and you'd like to work through it with the teacher, I do have a class going now. It's currently in Chapter 7. It's on Saturdays from 10 a.m. to noon. There's only 2 students in that class, so you would not have a lot of people in there that would be asking lots of questions. It would just be you and a few others. So feel free to reach out if you'd like help on that book going beyond that point. We use the AOPS book, by the way. Saturdays, there is a special class being announced. It'll be announced hopefully this week. I'm trying to get this off the ground for a long time now. It's going to be from 2 to 3:30 p.m. Pacific, which is 5 to 6:30 Eastern on Saturday. On Sundays in Beijing, it is 6 a.m. to 7:30 a.m., which is a little early, but I've got classes throughout the day and I don't know if I can move it. If anything, there's a star right here. The class that's going to be announced might be moved a little bit later. This will be a very special class I've never offered before, and more details on that when I'm ready to release it. The last class that I have is Saturdays, currently from 4 to 6 p.m. Pacific time. That's the AMC Fundamentals class. It uses Volume 1 as a textbook. We are currently in Chapter 6 of that book. And other classes that I can do, if you request it, are down here. Everything from the intro series. I could potentially put an intermediate class together if enough people sign up. I just need 3 or more students to sign up before I can run a class. If you'd like to sign up for these, you can find the information how to do so on my website on the Book Now page. I will link that in the description below. Having said that, let's go ahead and get to this preceding problem that we just talked about. And it's this one right here. I do have a longer explanation of this problem on my channel already that I did a few years ago per request from a student. But I'm going to go ahead and run through it right now in a little bit briefer explanation. And it's what is the hundreds digit of 2011 to the 2011 power? And one of the things we covered in that video is a strategy or a technique that you might not at first glance think of or even realize that it's connected. But because you've gone through past tasks, this is the 2011 task, and you've reviewed them and noted the key ideas, if you went into this year's contest with that information, you're much more likely to have a chance on the problem that we discussed, that we are currently about to solve on the board. Okay, and so how does it work? Well, one of the things you can do here is utilize binomial expansion. So if you remember a plus b to the n, every term that you do for this, for example, the very first term will be n choose 0, and then you will have a to the n, b to the 0. The second term is n choose 1, a to the n minus 1, b to the first. And the third term is n choose 2, a to the n minus 2, b to the second, and it just keeps going however many terms there are, okay? This value, the exponent on b in the general form, will always match this value here, so that the general term is always n choose k, a to the n minus k, b to the k power. And this is known as binomial, two terms, expansion by an exponent. So if you want to learn more about how to readily be able to execute this plan, a great chapter is chapter 14 of Intro to Counting and Probability from the Art of Problem Solving. I go over this concept extensively, both in my small notebook class and in my Intro to Counting and Probability class. So with this general term in mind, again, if you want the longer explanation, I will link the older video clip of this problem solved, which has much more detail in it that I'm going to go into here. I will link that in the description, and you can go watch that if this is a little bit less familiar territory to you. So how do we use binomial expansion here? Well, we're going to write 2000, which is our a value, plus 11 to the 2011 power. And note that we're only looking for the hundreds digit. Since this is a, if a is to at least the first power, it will always end in 3 zeros, and therefore not contribute anything to our hundreds digit. So the only term we want from this entire expansion is 2011, choose 2011, a to the 0, b to the 2011 power. And so when we do that, what does it mean? Well, b is 11, and this right here is 1, and that right there is 1. And really what this is equivalent to, right? Why do we not care about the other terms again? Because all of them end in 3 zeros at least, which means they don't tell us anything about the hundreds digit. So we're just going to go straight to, this is the only thing we care about, which is 11 to the 2011. And since we've already used this plan one time, we're going to use it a second time. And we're going to do a plus b to the 2011 again, but this time our a will be 10 and our b will be 1. And again, if you were taking this test back in 2010, this would have been very hard to think of. Or 2011, it would have been a very difficult concept. Not many people had seen this maneuver done before. And so as a result, you would have had a lot of trouble with this. That's why it was number 23. But fast forward now 13 years, and it's again appearing on the test as a concept, but people who have done their studying, they've gone through all the past tests. They've thought about these things. They've analyzed. They didn't just do it to get it right. They learned new techniques. They thought about it and said, you know, that's really an interesting mechanism. How fascinating that you can do this. You know what? I'm going to take a note about this. And why do they do that? Why do they take that note? Well, it's really simple. It's because they care. They want to learn. They have a very curious mind. They notice things like that, and they say, this, I'm going to file this away for potentially important later. And now you're taking the test in 2024. Again, a similar concept comes up, and you go, I remember doing this. I'm going to apply that same technique. That's how it works. A lot of modern questions are built on the backbone of older questions, which is a great reason that you should try one of the past test review courses, in my opinion. So next up, what do we do here? Well, if I have 10, which is my a to the third power, that will automatically end in 3 zeros because 10 to the third is 1,000. So I only want things where there's a squared. So I'm going to want, essentially, I'm going to zoom down here. I'm going to want 2011, choose 2, a squared b to the 2009 will be one of the terms I care about. Another term will be 2011. Oh, by the way, that's 2011, choose 2009. Yeah, so that's why that number has to match there, but it's equivalent to 2011, choose 2. And 2011, choose 2 is easier to think about, and it takes less time to write. If you want to understand why they're equivalent, go watch the longer video. I will explain it in detail in that video from 3 years ago. So then the next one would be 2011, choose 2010, which is equivalent to 2011, choose 1. And we're just going to write that here, and that will be a to the first, b to the 2010. And then finally, if I could just write that nicely, let's go back and write it again, 2010. And then finally, it's a 2 plus 2011, choose 2011, a to the 0, b to the 2011. Now, this entire term right here is just equal to 1 because n choose n is 1, a to the 0 is 1, and 1, which is what b is now, is also 1. And when you take it to any power, it's going to be 1. So the real two terms we care about are these two. And we're just going to calculate those now. It's 2011 times 2010 over 2. This is simply the shortcut that n choose 2 is equal to n times n minus 1 all over 2. Okay, write that one down. That's the small notebook concept. Okay, so you have that. Then you're going to have 10 to the second power times 1 to the 2009. From this point forward in your problem, you should stop writing the 1. Like it's going to be 1, right? We don't really care. So you can just eliminate that. And in fact, if I'm taking the test, I'm not even going to write that down. Okay, so on the next part over here, we will cancel the 2 with this to get 1005. And I'm going to do 2011 times 1,000, which is 2011,000, plus 2011 times 5. I'm essentially distributing 1,000 plus 5 like this. So 1,000 and then 5, right? So I'm going to have 10,055. Okay, and then what? That number still times 100. So if I add these together, the 10,055, really the only part that matters is this 055. And when you multiply by 100, the 10,000 is not going to contribute. None of this is going to contribute, okay? But times 100 will push this 5 into the hundreds position of that calculation. So now you'll have blah, 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 500. Okay, that's this 5 right here with the 2 zeros created by that. And now you're going to add 2011, choose 1, which will just be 2011 times 10, which is going to be 20110. Why 10? Because our a value again is 10. 10 to the first is just 10. Puts a 0 on the end. That gives us a 1. So now we have a 5 in this 100 spot, a 1 in that 100 spot. We're going to add those two together, and we're going to get 6. So I'm going to clear screen, pause it here if you need to get something off of it. I'm going to clear screen, and we're going to zoom in and look at this problem. And you're going to notice that 6 is the answer as answer choice D. Now again, because we went back, we reviewed the past tests, we learned from them. Then when you go into the modern test, or like you'll go into it next year in 2025, you are armed and equipped as long as you're reviewing your notes and recording key ideas somewhere. Where do you record them? I advocate for the small notebook. A link to that will be in the description as well. With all of this background in mind, let's get to the 2024 10B problem 18. It was also the 12B problem 14. Okay, so now after you saw that solution, let's go ahead and take a look at how that 2011 problem can impact the understanding of what we might try or think of trying here. And this is why it's not about just doing problems from the past. You need to analyze them. You need to ask, how could this concept come up again? How could I encapsulate what I learned in this problem and be able to use it on a different problem? Figure out a way to make a note for that. Put it in the small notebook where you're going to review it right before the test, because here's how it comes up and comes into play. How many different remainders can result when the 100th power of an integer is divided by 125? You say, man, how will I be able to do this? And you think, divided by 125, there's like a whole bunch of remainders, 100th power. This is going to get crazy. I mean, there's up to 125 remainders from 0 to 124, but they've got all this up here. Where do you begin? Well, that's where the insight comes from the other problem. You might think, I can represent every number in several ways. We might think to make it 125n plus the remainders, which would go, just r or something like that. But why 125, right? Why? You should be curious. Isn't this number have some property, like say it's 5 to the third power? Well, why did they pick a number like 5 to the third power? That is like a thread that you can attack. You can poke at it, you can look around, you can question that. It's like a breadcrumb. And so you say, maybe instead of considering it like this, what if I thought of every integer, and by the way, all integers can be written like this, you could think of it as 5n plus r. Every integer can be written this way, right? All it is, this is just basic number theory concept. It's a multiple of 5 plus the remainder when you divide by 5. And again, you'll say, okay, but why choose this? Well, for one, the remainders are a lot less. There's only remainders of 0, 1, 2, 3, and 4. And so you say, okay, but how's that going to help me get remainders of 125? Well, let's just inspect it and see what happens. What if I took this to 100th power? Now what does it look like? Does it look a little bit like 2000 plus 11 to the 2011 power? Right? Does it look a little bit like things we've seen before? It looks a little bit more like binomial expansion. And the thing is, let's go ahead and take a look at what the end result of this might look like. So again, any number that has this to the third power at least, right? So imagine I went to the very first term, okay? You've got 100, choose 0, a to the 100th power, b to the 0. This is your basic form, your general form. I often write in general form on my test and then plug in the values later, okay? Obviously, whatever this number is, obviously it's 1, but this number has a 5 in it, and 5 to the 100th power will always be divisible by 125. So this first term will contribute nothing to our remainder. Well, then what terms would contribute to the remainder? Well, at minimum, we're going to need our power of the a term to be less than 3. Anytime I have any a to the third, think about what that is. That's 5n to the third power. It's a multiple of 125. And if you have, let's say, 125x plus 125y plus 125z plus, 4, then the remainder is 4. Because these are all multiples of 125, then they don't contribute to the remainder, right? And so that's what's happening here with this. Then we want to avoid this term. So we're going to go ahead. Again, remember how we did that here too. Every term that had a 2000, we ignored, right? Our memory of how we did this, if you're able to recall it, is going to impact how you think about this problem. By the way, there is another solution to this. It uses something called Euler's totient. And it's, I don't know, maybe it's kind of advanced. I've never really mastered the technique. Maybe you have and you did that method and that's great. This explanation is designed for people who may not have learned that or have not mastered it, and they need a way to survive. Now, is it going to be as efficient or as perfect as Euler's totient? Maybe not. But at least you get 6 points, and it won't take that long. Let's go ahead and continue with our explanation here. So I'm going to erase this, and let's go ahead and peek at the final 3 terms of our expression. They're going to be 100 choose 98, and then you're going to have a to the second power b to the 98. Don't forget that this part here will always match that number, always, okay? And then you're going to have plus 100, choose 99, a to the first, b to the 99th. Don't forget the sum of these will always equal 100. This number is always that. These are little nuances of learning binomial expansion that help you quickly attack problems like this. That's why you want to pick up on these and not just be so formulaic, but make connections, make observations, okay? So now you're going to go ahead and go to the last term, 100, choose 100, a to the 0, b to the 100th. Now, here's the thing. What is 100 choose 98? Well, it's 100 times 99 over 2. Why is that? This is going to be equivalent to 100 choose 2, and you should have memorized that n choose 2 is n times n minus 1 over 2. It's a very nice shortcut, and you get to use it a lot in math competitions. So this would be 100 times 99 over 2 times 5n to the second. Wait a minute though. That's 5 to the second. That 100 is not going to lose any 5s. When I cancel this 2 into here, I'm going to have the 2 5s I already had. That means I've got 2 5s here and 2 5s here. That's more than 3 5s. And 3 5s is 125, and therefore this term does not contribute, does not play a role. Very similar to how things over here did not contribute. Now you look here, but you already, if you've perceived what we're doing, you should already realize this term won't contribute either. It's going to be 100 choose 1. You get 2 powers of 5 here. You get 1 power of 5 here. We can disregard this. This is the importance of making and understanding what you're doing during the test. You're going to streamline your solve process. Okay? So the final point is all that matters. This is the only thing that's going to impact our remainder when dividing by 125. This is like your 125x, your 125y. This will be the remainder, or the only thing that contributes to the remainder. So that brings us back to b. What is b? b is the remainder. When this number here is the remainder when dividing by 5 only. That doesn't mean that those remainders are going to apply here the same way, but we only can get 5 different remainders here, and they're all going to be something we have to check or inspect or look at. So those remainders that are possible are 0, 1, 2, 3, and 4. And we need to take them to the 100th power. At about this point in the problem, I would say you're at about second base. Okay, maybe halfway between second and third. This is an analogy for how close you are to finishing the problem. There's still some legwork to do. Okay, let's go ahead and erase this. Let's erase this. I'm going to need board space. We've got these remainders to check out. Okay, so if I took my remainder, 0 to the 100th power, that's still 0. And that would mean that it doesn't really contribute anything at all. So any multiple of 5 would automatically give you, 5 to the 100th power. It makes sense. There's going to be no remainder for 125 either, right? So anytime the remainder here was 0, I would just have a multiple of 5 to the 100th. Clearly, the remainder of 125 would also be 0. So we can definitely get r equals 0. Similarly, if I had a remainder of 1, 1 to the 100th is going to be congruent to 1 mod 125. Okay, so that's going to be also possible, r equals 1. We have those two now going for us. Okay, now briefly, I'm going to go ahead and look at the other remainders of 2, 3, and 4 and think about how they work. But you might want to check out also solution 3 in the AOPS forum. At the time I filmed this, it was solution 3. Maybe it got bumped or something. But somebody there took advantage of symmetric effects. I'm not going to do that here. I might mention it if I can think of it at the end, but I'm going to continue with my process for now. Why am I not going to mention that way? Because maybe you don't perceive that way. Maybe you don't catch that way when you're doing it. It is a very cool technique. Hat tip to whoever wrote that solution. Very good thought for them to have. That's somebody who's really mastered the concept of number theory, and they're aware of different tools they might use to make their solve process more efficient. So the next thing's going to be r equals 2. And we need to find out, if I take 2 to the 100th, what is my remainder? Okay? I could also do it with 3 to the 100th, but we're going to do it with 2 to the 100th and see what happens. Okay, so let's get rid of these. I'm actually going to get rid of that too. We're going to get rid of all of that. I just need board space. So yeah, we'll be fine. So 2 to the 100th. Here's the thing. How am I going to find the remainder when this is divided by 100? Keep in mind, as of right now, this is your maximum answer, and we already have this one. If any one of those remainders, 2, 3, or 4, gets knocked out as one of these two, meaning it doesn't contribute a new remainder, then guess what happens? Well, that would mean that this is the answer right here, because we can't get to 5 anymore. And so you can just say, hopefully, you're kind of hoping, if you get one, this is the answer. If you don't get one, that's the answer. Pretty simple. You don't have to check all of them at this point. So how do we advance? Well, I don't know. We got to find some power of 2 that gives us a nice remainder when we divide by 125. A couple options come to mind. You could do 2 to the 7th power, because that's equal to 128, and 128 is congruent to 3 mod 125. And you could proceed that way by stacking 2 to the 7ths. How many would you get? You would get 14 of them, because 7 times 14 is 98, and you would additionally have a 2 squared. So you could do it with that. You'd be using 3 to the 14th times 4. You're modding out, by the way. You mod out 2 to the 7th mods out to 3, times 2 to the 7th mods out to 3, times 2 to the 7th mods out to 3. If you don't know what modding out is, you're going to have to look up some number theory stuff to understand that. I'm not going to explain it in this video. I do have videos, modular arithmetic intro. I'll try to link it in the description. You can get an overview of some basics of it. I've done it in some problems in the past, so I'm not going to do it here. So this would be like 3 to the 1st, 3 to the 1st, and you get 14 of these, so you would get this. Where's the 4 coming from? Because you have 2 to the 98, which is 14 groups of this, times 2 squared, which is the 4. Now, you could continue with this process and try to do this with 3 also. I'm not going to do that because it's not very, it doesn't do very well with the 3s. In my opinion, it was kind of harder to calculate. Instead, what I did, I didn't use the 2 to the 7th. I thought about the fact that we have 2 to the 100th. It's like 2 to the 10th to the 10th. And 2 to the 10th, it's pretty easy to remember. The 1 0 right here, you just copy it and then attach 24. And the thing about 1,000, it's a multiple of 125. 8 times 125 is 1,000. So then this would be congruent to 24 mod 125. And the thing is, you have 10 of these. And the fact that 24 is 2 to the 3rd times 3 to the 1st, you're going to get this. And this is now to the 10th power. So where does that put us? It puts us at 2 to the 30th times 3 to the 10th. And I guess we're getting quite a few of these powers of 3 after all. In fact, we might just end up right back where we were a minute ago. The 2 to the 30th, though, is 3 more 2 to the 10ths. So 3 more 2 to the 10ths is 3 more 24s when we mod out. Every 2 to the 10th mods out to 24 mod 125. So now you're going to have 24 to the 3rd times 3 to the 10th. And of course, that's going to be 2 to the 9th. 2 to the 3rd is 2 to the 9th. And you're going to have 3 to the 3rd and 3 to the 10th. And I think we are going to get right back to where we were. So 3 to the 10th, yeah, we are. How about that? I never realized it till just now. So 3 to the 10th, you're going to be 3 to the 13th. And then how does this 2 to the 9th work? You have the 2 to the 7th times 2 squared. And we already know what 2 to the 7th mods out to 125. It's a 3. And so now you are at 3 to the 14th, right where we were a moment ago. It's the exact same path. Oh well, I'm not going to refilm. We're just going to deal with the surprise. So 3 to the 14th times 4. At this point, you're going to have to find some kind of way to get where you're going. It just depends on what you want to do. I might do 3 to the 5th. What is that? That's 243. And then you're going to have 2 of those. Notice that they're both -7s. 243 is congruent to -7 mod 125, meaning it's 7 below a multiple of, let's see, that would be true, right? -7 mod 125, then because 250 is a multiple, so I would do 250 and then -7 to get there. So yeah, and then you have how many of these? You kind of have 2 of them. You have 3 to the 5th times 3 to the 5th times 3 to the 4th, which is 81. So you're going to have -7 times -7 times 81. Now, how short of 125 is 81? We could either leave it as 81 or maybe we could multiply the 81 times this 4 to get 324, and you would notice how short are you of 375? You would be 51 away, so you'd be negative 51. So at that point, you now have 49 times negative 51. Kind of don't want, I guess we could use it with the negative. Let's just think, what's the best way here? We'll do 49 times, maybe I should just add 125 to that. Let's do that. I don't know, I don't want to risk it with the negative. It's kind of weird sometimes when you're in the negatives on this. So if I add 125 to 51, I would be at, what's 125 minus 50? 75. I take away one more, you're at 74. So you're at 49 times 74, okay? So I'm gonna do 74 times 50 minus 1, okay? 5 times 7, you're at 350 with 20 more is 370 with a 0. And then you're subtracting 74, so you're at 3626. Let's think about multiples. We already know that 3,000 is a multiple of 125. So you have 3,000 plus 625 plus 1. Notice divisible by 125, divisible by 125. It mods out to a remainder of 1, which we already have, which means that's out of the question, which means that's the answer. So all of this, is it beautiful, amazing, wonderful? No, but it's 6 points. And sometimes you're not always going to go into battle on the test with knowing every single possible skill that you could possibly have ready to go. That takes just a lot of knowledge, a lot of time, but you might still have enough skill to be able to get a question like problem number 18 correct, as long, you can take probably 5 minutes on this problem. If I'm not talking to you, maybe 5-6 minutes or something like that with this kind of a solve process. Little bashy, but again, your ability to quickly process all of this will definitely play a role. And maybe you didn't get it pretty with Euler's totient theorem, but you still got 6 points. Okay, that's it for this one. See you in the next one.